So this first one is 3 to the x. It would be really nice if you would think, okay, is there any way I could get 729 to be 3 to the something? Right? And the only way you can really do this is just start and go, well, 3 times 3, that's 9. It's not going to take a long time, because when you start multiplying by the same number over again, it gets big fast. So if we do another 3, that's 27. Times another 3, that's what, 81? Times another 3, that is 243, I think. Yeah, 243. Times another 3. That's it, 729. So I have 1, 2, 3, 4, 5, 6 threes. So that means I can absolutely say, well, 3 to the x is equal to 3 to the 6. So, and I'm just going to check. It's not a bad idea to check yourself in the calculator, but I'm typed in 3 to the 6, it is 729. So we got that part right. So, I mean, this is, if the bases are the same, then you say, well, x is equal to what then? 6. There's no solving to be done there. That's just, so on this one, you really want to do, what you really want to see is, you need to see if you can get 1296 to be 6 to the something. That's the goal, because if you can, then you're going to say 6 to the 9x is equal to 6 to the whatever you get for that. That's what you need to do on that. Okay, this one. 31 is a weird number. I know already by just looking at this, there's no way I'm going to get 31 to be 4 to something. That was what I would try to do, right? But it's not going to happen. Whenever you have one like this and you know it's not going to work, you automatically go, oh, if it has an e in it, you would do the natural log, but it doesn't. So I got to take the log of both sides of this. It's the only way I can solve this. So you would move the x in the front. So you go the log base of 4, or sorry, the log of x times the log of 4 is equal to the log of 31. Divide both sides by the log of 4. And so x is going to be the log of 31 divided by the log of 4. And they're wanting us to round to, not round until the final answer, then round to 4 decimal places as needed. So this is number 3. Coming up with 2.4771. Okay. Are y'all okay with that? So, I mean, we worked this type, this shouldn't be too difficult. Like you should be, these are a little bit not too bad. I'm looking at this and I'm saying, oh man, it would be really nice if I could get 81 to say 3 to the something. I mean, can we get 81 to say 3 to the something? 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1, 2, 3, 4. So 81 is equal to 3 to the 4th. I'm not going to work the rest of this out, but you've got 3 to the 8x minus 7 is equal to 3 to the 4th. So then you would say, well, 8x minus 7 is equal to 4. Y'all are okay with that part, right? Okay. We can do that one. I'm 100% sure that there's no way that I can get this 3 to be 2 to the something, because that would be the goal. If this is a 2 to the something, I want this to be a 2 to the something. Well, that doesn't work. So on this one, you would have to take the log of both sides, because you can't get it to be 2 to the something. And that would be the first step. Okay. What would be the next step? Move the x down in front. So x log of 2 is equal to the log of 3. Divide by the log of 2. These are going to cancel. So we get x is equal to whatever the log of 3 divided by the log of 2 is 1.5850. it would be really nice if I could get both of these to either be 10 to the something or 2 to the something, but 10 will not turn into 2. There's no power of 2 that is 10, and 2 won't turn into 10. So I'm going to have to move to that step where I would say the log of 10 to the negative x is equal to the log of 2 to the 3x. Because that allows me to bring that negative x down front and the 3x down front. Okay. On this problem, so we're wanting to get all the x's on the same side of the equal sign. And right now we've got them on 2 different sides of the equal sign. So I'm going to have to subtract. I'm going to have to get like set this thing equal to 0. This is one of the ones I'm saying we did not work something this difficult in class. So on the note, so subtract 3x times a log of 2 for both sides. That would get me negative x log of 10 minus 3x log of 2 equals 0. Okay. Remember that the goal is that you're trying to get x by itself. Let me slow down a minute. So all I've done is move that other thing over there and set everything equal to 0. Now, there is an x in both of these terms. And when that happens, what you want to do is pull that x out front. You want to leave everything else in the parentheses, but you're going to pull that x out of each term. So if I just take the x out of this negative x log of 10, I've got negative log of 10 left because I moved the x out front. If I take the x out of negative 3x log of 2, I still have left negative 3 log of 2. This whole thing, if we type negative log 10 minus 3 log of 2 is just a number. All right, so I can divide by the negative log of 10 minus 3 log of 2. If I divide by it on that side, then I have to divide by it on the other side. So I'm going to do 0 divided by that. Well, 0 divided by anything is 0. And this would cancel out with this because they're the same on the top and the bottom. And so I just have x is equal to 0. That's one of the ones I wanted to make sure that it's more difficult than the problems we were working in the notes. That's how you're going to do that one. Anybody need more time to copy that one down? Okay, this one's not bad. There's no way I can get 703 to be e to the something, but this is, I'm not going to work this whole problem out, but when you see this, you should just go, I can just take the natural log of both sides. I'm just going to put hint on this one. Take the natural log of both sides. Then you're going to bring that t down front. You're going to be able to move from that because you can solve it after that. Do y'all understand what I'm saying? Everybody okay with that one? Bring the t down front? Okay. That's the hint on that one. I think the same thing on this one, right? Let's just do a hint. So since there's no way I can get 0.17 to be e to the something, I'm going to say, well, let's take the natural log of e to the negative 0.19t and let that be equal to the natural log of, natural log of 0.17. You move that negative 0.19t down to the front. Then you're going to divide by the negative 0.19 and the natural log of e. That one's is like what we were doing in the notes a lot. Number 9. 15 to the x is equal to 5 to the x plus 1. It would be really nice if I could get 15 to be a 5 or 5 to be a 15. But 5 times 5 is 25. So 5 squared is never going to turn into 15. 5's not going to turn into 15. 15's not going to turn into 5. So you immediately know, okay, I have to go the log. I'm going to have to do the log of both sides because I'm never going to get those bases to be the same. When you do that, you're going to bring your base. This one's a little bit difficult, so I'm going to work this one. But x log of 15 is equal to, and I'm moving this whole x plus 1 down, and I'm putting it in parentheses so I know that it's not just 1 times log of 5, it's x plus 1 times log of 5. I want to make sure I know that that's that whole thing. Okay. I'll kind of scoot this down. I can spread this part out and say, it's kind of like the distributed property and say, this is the same thing as x times the log of 5 plus 1 times the log of 5. Are y'all okay with that? I just took the x and made it go with it and the 1 and go with it. We can't have x's on both sides. So I need to get all the x's on the same side so I can kind of group them together. So I'm going to subtract an x log of 5 from both sides of my equal sign. So I would get x times the log of 15 minus x times the log of 5 is equal to 1 times the log of 5 is all I have left. And 1 times the log of 5 is just the log of 5. I can factor out. I need to get these x's together so I can pull, since there's an x in both of them, I can pull that out and say, okay, if I take the x out of log of 15, I just have log of 15. If I take the x out of negative x log of 5, I just have minus log of 5. So the next step would be to divide both sides, trying to make room. But I need to divide both sides by the log of 15 minus the log of 5. These cancel out. The answer is going to be whatever x is. So x ends up being the log of 5 divided by the log of 15 minus the log of 5. You want to make sure you type in that whole, like maybe find the answer to the top, then find the answer to the bottom and divide them, or make sure you're typing it. You could use your alpha y equals and do that. But your answer is going to be 1.4650. Yeah. Okay. Y'all good? Okay. This one is the third type of problem we were solving in our notes. Remember, if you're looking at a logarithm, you immediately go set it up as an exponent. So you go, okay, well, 4, the first power is equal to x. So 4. That one's easy. If this doesn't have a base and you're looking at a logarithm, then you know it's the 10 is going to be your subscript down here. So you've got 10, skip, come back. So 10 to the negative 2 is equal to x. So that means that you're going to have 1 over 10 squared, which is 1 over 100. It does not want your answer as a fraction, so you would divide 1 divided by 100 is 0.01. This is, here's, I'll do a hint. I'm not solving this whole thing out. We'll never get done. So this is a logarithm, so we're writing it as an exponent. So 5 squared is equal to 2x minus 6. Okay. Do you guys remember in 8.5 when we talked about properties of logarithms and we said if you are adding that, if you want to squeeze them back together, that's the same thing as multiplication. That's what you have to do on this. You got to recognize, okay, I got 2 logarithms. I'm going to have to squeeze these in together to be 1 to solve this. So you would say, okay, I'm putting the log of x times x plus 21 is equal to 2. And this is the base of 10 because there's nothing down there. So now that you've got it as 1, you can do the trick where you go, okay, 10 squared is equal to this. 10 squared is equal to x times x plus 21. Ten squared is 100. So then you'd use the distributive property here. X times x is x squared. X times 21 is 21x. That's quadratic, right? We're solving something that's quadratic, so we have to set it equal to 0. We would subtract 100 from both sides. So 0 is equal to x squared plus 21x minus 100. What can you use to solve a quadratic? You can either factor it or you can use the quad program, right? So if we go to the quad program and we type in A is 1, B is 21, C is negative 100. Or and negative 25, that's what you're getting. Okay. So we know that the answers would be 4 and negative 25. Okay, now here's where you got to be careful. I don't know what you cannot take the log of a negative number. So if I was to go back and plug in this negative 25 for this x, the log of negative 25, the calculator is going to say, you can't do that. So let me just show you real quick. So if I went there and I said log negative 25, can't do that. So it's going to let me take the log of 4. That's going to be fine. So log of 4, we have a number for that. So on those, you've got to be careful and go back and plug them in your original formula. I do have a log of x, and so 4 works. If I plug 4 into this, 4 plus 21 is 25. That's positive. That's going to be fine. But if I plug negative 25 into either one of these x's, it's going to make both of those negative. It can't happen. So the only one that's correct is 4. This one doesn't work here. You can't have a log of a negative number. Okay. This is work similar. We are subtracting. What goes with subtracting if we're going to force them back together? Divide, right? So we've got to push them back together. So they're both log base 2s of b plus 24 over b plus 6 is equal to the log base 2 of b. Since these 2 things, they're both a log base 2, since those are the same, now I can just go straight to saying that, well, b plus 24 over b plus 6 must be equal to b then. If you multiply by b plus 6 on both sides, then that will get rid of this. This will get rid of this b plus 6 on the bottom, which does help. we would get b plus this. Now y'all see why I wanted to work these, because they are turned up a notch. B times b is b squared. B times 6 is 6b. This is going to be quadratic. So I can tell that because I've got a b squared in here. So I need to get this equal to 0. I can subtract b. So that would be 24 equals b squared plus 5b. And then I would have to subtract the 24. So that gets me equal to 0, which is what I need. Once you see it's quadratic, what are you supposed to use? Quad program or factor it, whichever way is easier for you. But if I use the quad program, I can pretty easily find out what my answers are. So A is 1, B is 5, C is negative 24. I'm getting 3 and negative 8. We need to be worried about one of them. Which one do we need to be worried about? Negative 8. We want to look at negative 8. If we go back up and plug in negative 8 for B here, negative 8 plus 24. Well, negative 8 plus 24 is not going to be negative. It's going to be positive. So that's okay. If I plug in a negative 8 right here, negative 8 plus 6, that's going to be a negative 2. That's not okay. And if we plug in a negative 8 right here, that definitely is going to be negative. So 3. But I do want to know, if it was just this, it would have worked. So you do have to go back up there and make sure it doesn't work, because it's possible that it does work. 3 will definitely work. Okay. So 15, 16, and 17. Subtracting. So that means we are dividing. So if we want to put this back together, we would say the log base 3 of x plus 1 over x is equal to 4. On this one, we would go 3, skip over the middle, come back to it. So we would write it as an exponent and say, well, 3 to the 4th should be equal to x plus 1 over x. 3 to the 4th is 81. 3 times 3 times 3, yeah. I would then multiply by x on both sides to get rid of this x in the bottom. So I would have 81x is equal to x plus 1. This is not quadratic. I don't have an x squared. I just can solve this by subtracting x and saying, well, 80x is equal to 1. Divide by 80. So the answer is 1 over 80. On 15, they want the answer to, yeah, that's it. You can write it as a fraction. Leave it. We are adding, which means to multiply if we squish it back together, right? So the log base 5 of x times x plus 1 is equal to the log base 5 of 6. Since we've got logs and they're both the same on both sides, you can cut that part out and just say, well, then x times x plus 1 must be equal to 6. So we're going to distribute that x and get x squared plus 1x is equal to 6. This is definitely quadratic. So we could subtract the 6 from both sides and get x squared plus 1x minus 6 is equal to 0. We could use the quad program to get what x is equal to. We're probably going to get a positive and a negative, right? And so if if you are following on Zoom, what are the roots of that? X squared plus 1x minus 6. I'm getting 2 and -3. We know that 2 is probably going to be okay. -3 could be a problem. If we plug in -3 here, it's a problem because you can't take the log of the -3, the base of 5. So it can't happen. So this one's not going to be an answer 2. Homework. Last question. And I think you'll be glad that you have these notes when you start working your homework. It'll make it kind of be smoother. If we're adding, we're multiplying if we want to put these back together. So we're going to have the log base 3 of x plus 4 times x minus 4 is equal to 2. I don't have logs on both sides. If you don't have a log on both sides, you can't do the thing where that stuff cancels out. You're going to have to write it as an exponent. So you're going to have to say, oh, that's 3 squared is equal to x plus 4 times x minus 4. Nine is equal to. This is where you do all that FOIL pretty stuff, or you could realize that this is the difference of squares. It ends up being just x squared minus 16 because those cancel out. So we want to set this equal to, actually this one's really easy to, we don't need to use a quad program. You can set it equal to 0 and use a quad program, but really just add 16. That's 25 is equal to x squared. So x is equal to positive or -5. We already know -5 is probably not going to work, but if we go up here and -5 plus 4 is going to give us a -1, so 5. So that we've not seen one where the negative works. So the best bet is if you don't know if the negative one works, it's probably not. But it is possible that you could add a number to that negative number that makes it big enough to work. Does that make sense? Like if this was a plus 10 and this one over here was a plus 10 too, or a plus 12, it would, if it turned it back to a positive, it would work. Okay, so the goal in the lab today is not 9.6, it's 9.5. If you could get through 9.6, that would be super fabulous, but the goal to get your points today is 9.5. And I'll meet y'all over there. Any questions about anything else? Okay. I would strongly encourage you before you come back on Monday to try to get caught up with what 9.6 so that you're ready to go. 9.7, like get the rest of it done, because then you're going to be able to get that test over before Thanksgiving. And that's going to make you happy. And you'll just come back and study for your final. That's the best case here. Okay.